Hello and welcome to the QSO Today Expo introduction to the Nano VNA presentation. My name is Greg, WA1JXR. I will be your host today. Thank you all for coming. Let me share my screen and get the presentation in place. Okay. So today I'm going to show you an introduction to the Nano VNA network analyzer. Hopefully this will help you figure out how to use the excellent tool. Okay, here are some of the things we're going to talk about today. I won't read them all off, but you can see it covers a variety of topics, and we'll cover basically all you need to know about the Nano VNA and different measurement types and how to calibrate it and so forth. A little bit about myself. First licensed in 1967, upgraded to general and extra. My ham radio led me to a career in electrical engineering. I earned a couple university degrees. After college, I started working for Raytheon Company, and I worked for them for 42 years as a RF microwave design engineer working on radar systems. I retired in December or at the end of 2019. I'm not a contester or a DX chaser, just a good old rag chew operator. I enjoy restoring old vacuum tube radios. And I'm also active in the New England QRP Club. I like getting on with the old radios, putting them on the air. And of course, my main mode of operation is CW, or what I call the original digital mode. I'm also active with the ARRL here in the Western Mass section. I'm assistant section manager and technical coordinator. So what is a network? Since we're going to talk about network analyzers, it would probably be good to know a little bit about what a network is. And a network can be pretty much anything, and some electrical circuit or whatever. And a one-port network is a network that has only one RF connector on it. And some typical one-port network devices that we would see as hams is, well, our amateur antenna is a one-port network, or an RF dummy load, or a transmission line shorted or open stub that would be considered a one-port network. We also have two-port networks. Some typical devices for those might be an RF amplifier. Actually, a piece of coax, a transmission line, since it has, connectors on each end, would be considered a two-port network. An RF filter, or maybe some phasing lines for a phased antenna. So when we're measuring RF networks, it gets a little bit more difficult. When we're dealing with circuits in the audio or IF or lower frequency ranges, we can go in there with voltmeters and scopes and easily measure voltage and current and various parameters and figure out what's going on in the circuit. But when we get into RF circuits, because of the higher frequencies involved, it becomes very difficult to just go in there and measure voltage and current. As soon as we get in there with a probe and start trying to probe the circuit, because of the sensitive parameters and the higher frequency, we changed the operation of the circuit. So we needed to have a way to look at RF circuits, in their characteristic impedance in a 50 ohm environment, for example. And so one way to do that is to just use the existing connectors on the network and look at the power going in and being reflected back from the network. And that can be looked at similar to light going through a lens. Here you see a lens. It has some incident light going in. Some of that light is reflected off of the surface of the lens, but some of the light goes through the lens and is transmitted through. And so you see the signals there, R, A, and B. Well, these same kind of signals can be used with RF networks. We apply an incident signal, we look at the reflected signal, and if it's a two-port network, we can also look at the signal transmitted through. And so from doing a ratio of the reflected signal to the signal coming in, we can calculate things like SWR and impedance and return loss and something called S parameters. But also looking at the signal, if it's a two-port network that's transmitted through, we can calculate things like gain or loss, insertion phase, group delay, a bunch of parameters that we can calculate about the network. Here's just a different way to look at it. So these signals going in and coming back and being reflected from the network, in engineering, they refer to these as scattering parameters or S parameters. And there's 4 of them. Well, it's what's called 2 forward and 2 reverse. And they're called S11, S21, S22, and S12. And the way to kind of remember it is the S stands for scattering. The first number is the signal is applied to the first number, and then you look at the signal coming back or coming out of the second number. So if we would take, for example, S21, it would be the signal at port 2 when a signal is applied to port 1. And S11 would be the signal at port 1 when a signal is applied to port 1. So that would be the reflected signal from port 1. Block diagram of a network analyzer basically looks like this. You have a signal source. The signal source is typically split. And so one side of the splitter goes to a receiver called R, and that's the reference receiver. So that's an exact copy of the signal that you're putting into the network. The other signal goes into the network. You can see here, comes out of port 1 and goes into the device under test. That thing at the junction of port 1 there is what's called a coupler, directional coupler. And then any signal that's reflected back from the device under test back into port 1 gets coupled through that coupler and goes to receiver A. If you're dealing with a 2-port network and the signal goes through the device under test into port 2, the signal coming out of the device under test goes to receiver B. Now let's take a look at the Nano VNA. You see it has 2 ports. They're SMA type connectors. One is called the TX out and the other one's called the RX in, or sometimes referred to as channel 0 for TX out and channel 1 for RX in. It has a USB connector on it. It's got a couple LEDs to let you know that the thing is live and the battery is live. It's got an on-off switch, and then it has a multi-function switch that is a press button, or you can push it left and right to kind of rotate it. It has a colored touch screen. One of the things that I always recommend to people who have the Nano VNA is the SMA connectors are excellent RF connectors, but they're small and they can be damaged, and they do wear a bit. So if you're constantly connecting and disconnecting to the SMA connectors over some period of time, they will wear. So what I recommend is putting on connector savers. Go out and purchase a SMA male to SMA female adapter, and then just screw that adapter onto each of the SMA females that comes on the Nano VNA. And now you have 2 SMA females that you can connect to. But if one of those connectors gets damaged, Now all you have to do is take the connector saver off, put a new one on, and you haven't damaged the connector on the Nano VNA itself. Here are the specifications for the Nano VNA. This is sort of one of the older ones that goes up to 900 megahertz. They have some newer models now that go up to 1.5 and even 4 gigahertz, I think. But you see it puts out a very small signal, about 1/10 of a milliwatt. It has pretty decent dynamic range, 50 dB at the higher frequencies. It has the touch screen, the USB interface, built-in battery power. When the points sweep across the screen, it has 101 points that it uses. And this is one of the biggest disadvantages, but we'll talk about a way to get around that. You can put 4 traces on the screen at a time and 4 markers. Marker is a little blip that you put on the trace, and it shows you what the frequency and the value of the trace is at that point. And it also has 5 memories where you can store things. The source in it is pretty good, 0.5 parts per million error, which means at 100 megahertz, the error is only about 50 hertz or so. Here is a block diagram of what's inside the Nano VNA. You can see the various things that make it up, and I'll walk you through this block diagram and show you how it works inside. So let's look at a reflection measurement known as S11. This is what you would use when you're measuring SWR and trying to measure an antenna. So what happens is when you set up the Nano VNA for start and stop frequencies, it sweeps over that frequency range, and it commands the source in the Nano VNA to put out a signal. That signal is applied to something called an RF bridge. The source also puts out another signal called a local oscillator. That signal is sent to 3 different mixers. What those mixers do is they take the signal that you're trying to measure and they down convert them using the local oscillator to a lower frequency, so the analog to digital converter in the Nano VNA can digitize it and convert it from analog to digital. So also the signal that's applied to the bridge is sent to one of the mixers there in channel 2, and therefore that signal is down converted and sent to the D to A converter and is known as the reference signal. The signal from the bridge is sent to the device under test, and since this is a reflection measurement, this would be a 1-port device like an antenna or something like that. That signal that's sent to the 1-port device, any signal that's reflected back from that 1-port device connector comes back to the bridge. The bridge separates that reflected signal and sends it over to channel 3. It's down converted by the local oscillator again and sent off to the digitizer in the Nano VNA. The Nano VNA's microprocessor then takes the ratio of the reflected signal to the reference signal, and from that it can calculate the SWR, things like return loss, and a bunch of different parameters. Can actually calculate the impedance of the device under test. Similarly, when we're measuring a 2-port device, same thing happens. We have a signal that comes out of the source, goes to the bridge. We also have that local oscillator signal that's created as well. The reference signal is measured just like with the previous case. The signal from the bridge is sent to port 1 of the device under test. Now, because this is a 2-port, the signal goes through the device under test, and then comes out of port 2 of the device under test and goes into and down converted in channel 1. The microprocessor then does the ratio of the through signal in channel 1 to the reference signal, and from that it can calculate things like gain or loss, insertion phase, group delay, a bunch of different parameters about the 2-port network. Here's what the inside of the Nano VNA looks like. It has, you see the 3 different mixers there. You see the 2 SMA connectors on the right. The phase lock loop, that's the PLL, that's the signal source. Right below that is the analog to digital converter chip. And then just to the left of that is the microprocessor, the CPU. And then above that, you see some battery charger circuits. And of course, the switches and stuff, and the USB connector at the top. And then, of course, the built-in battery as well. Now, when you're dealing with measuring RF networks, as I mentioned before, it's always difficult to measure high-frequency RF signals because the thing that you're using to try to measure it with often has some errors associated with it. There's no such thing as a perfect measuring device. And so in order to, and the Nano VNA is no difference. The hardware in the Nano VNA, when it measures the RF signals, will have some error with it. And so what we need to do is we need to figure out what those errors are by a method called calibration. And we do that using what's called a SOLT calibration, and that stands for short open load through calibration. When you buy your Nano VNA, it comes with what's called a calibration kit. So there's a little short circuit, an open circuit, a precision load, and then a little cable so that you can do a through connection. And so what happens is it knows exactly when you put that short circuit on there. We know exactly what a short circuit is from an RF point of view. But when it does the actual measurement, it notices that there are some errors. It's not measuring what an ideal short should be. So what the calibration software does is it figures out what those errors are, and it stores those errors so that when you actually do a measurement, it can use those errors that it's stored, take them out of the measurement so that the measurement you're getting is error-free. And so it does this with the short, the open, and the load, and the through. It stores all of that stuff. And when you then do the measurement, it uses those what they call error vectors to take the errors away from your measurement, and you get a very accurate RF measurement. Here are the errors that it actually looks at. This is called a 12-term error model. There's 6 forward and 6 reverse errors that it looks at. Things like source and load match errors, crosstalk between the input and output ports, directivity of the coupler, that's leakage that comes through the coupler, and the fact that when you measure an RF device over some frequency, the measurement varies with frequency a little bit, so you get these what's called frequency response tracking errors that it takes out as well. When you get the Nano VNA, when you buy one, there's not much documentation that comes with it. So I thought I would go over a little bit what the memories look like. When you press the multifunction button and you come to the home menu, you see that it has a bunch of things in it. If you hit display, then you get the next menu where you can select up to the 4 traces that you want to see on the screen. You can also select the format, whether you want it to be log magnitude, whether you want to look at phase or delay. You can look at the information in Smith chart format. or you can look at SWR. And then there's a bunch more where you can actually look at the real and imaginary parts of the impedance. There's also a okay, so that's pretty much all for the display. If we now press marker, you can go and select up to 4 markers that you can put on the trace. And what a marker is a little like blip on the trace, but associated with that blip, you get a readout of what the value of the trace is. It tells you what the frequency is and what the value of the trace is. If you're looking at, if it's a trace of SWR, then it shows you what the SWR is at that particular frequency. Stimulus, when you're setting up the network analyzer, the network analyzer typically sweeps over a frequency range. And so you have to put in a start and stop frequency. You can put it in by entering the center and then the span, which is the width. I find putting in the start and stop is easier. Or you don't have to have it sweep. You can do the measurement at a single frequency, and that's what the CW frequency is for. When you do the calibration, it walks you through putting the open short load isolation and then doing the through. And then when you get done with that, you hit done, and then it gives you the option to save that calibration in one of 5 different spots. If you have a particular setup that you want to maybe use quite often, you can set the Nano VNA up for that particular thing that you want to do, and then you can save that setup into a memory location. And then if you want to go back to it, you can just hit this recall button, recall the location where you saved it, and all those things will come back into the Nano VNA that you set up the first time. The configuration button is mainly used to, you can do a calibration or do a test of the touchscreen. You can also look at the version of the firmware and or download new firmware into the device from this point. Like I said, the Nano VNA doesn't come with a lot of documentation, but there's a great Nano VNA user groups on groups.io, Nano VNA-users at groups.io. You can find, and there's all kinds of information, text information, videos, all kinds of information. I would highly recommend that you join the Nano VNA user group. There's also some free software that you can get from that Nano VNA user group. It's called Nano VNA Saver. And here you see a picture of what the Nano VNA computer screen looks like. It's free, and you can just download that into your PC, and then through the USB port on the Nano VNA, it connects to the Nano VNA, and you can, rather than having to hit the touchscreen on the Nano VNA, which is a little on the small side, you can use this software to control the Nano VNA. It's quite nice. So let's take a look at a typical ham radio measurement with the Nano VNA. Let's measure an antenna with the Nano VNA. And remember, as we mentioned, an antenna is a 1-port device. So you'd have to set the start and stop frequency to cover the range of the antenna, and then calibrate the Nano VNA with the open short load through once you've set up that frequency range. And then you connect the antenna to the TX port or channel 0. You set the display to like a signal trace. And then you could set the trace format for SWR, and you could read the SWR of the antenna. I'm going to, what I'm going to measure is a a duo band antenna that I have that I use with my HT. It's a 2 meter, 70 centimeter antenna. So I'm going to stop sharing right now. And so here's the setup that I have with the Nano VNA. You can see the I have the antenna plugged into the Nano VNA and then connected with the USB cord back to the computer. And if I now share the screen for the Nano VNA saver, you see the screen for the Nano VNA saver. I've set it up so that it sweeps between 100 and 500 megahertz because I wanted to cover the 2 meter and the 70 centimeter bands. I've set it up for a single trace, and I have it in SWR format. So down at the very bottom, that's an SWR of 1-to-1. Up at the very top, that's an SWR. It looks like 25-to-1 or so. So here you see the trace that I got when I measured that dual band antenna on the Nano VNA. And I've set up 2 markers. You see there's a red marker and a green marker. A little hard to see here, but the red one is at 146 point something megahertz. So that's in the 2 meter band. The green marker is at 440 megahertz. That's in the 70 centimeter band. And you can see the little red blip there and the little green blip over here. But you look on the screen here, you can see the readouts. And for the 2 meter one, it's showing an SWR of about 1.5-to-1. And for the 440 marker, it's showing an SWR of like 1.49-to-1, so just about the same, 1.5. So a good match to the antenna at those two operating frequencies. The one nice thing that you get with this Nano VNA saver software is, remember, I mentioned in the specifications that the analyzer itself, the firmware in the analyzer, only can break the start and stop sweep up to 1,000 points. And when you're dealing with a large frequency range like this, each step would be, 10, 20 megahertz or so. And so when you're trying to do a measurement over a wide range, that wouldn't work. But what this software allows you to do is to put in segments. And so what it does is in every segment, it uses the analyzer, and it gathers those 1,001 points for every segment, and it breaks this whole start and stop range up into, in this case, I've selected 100 segments. So you get a lot more resolution and a lot better measurement by doing that. Okay, I'm going to stop sharing that screen, and we'll go back to the PowerPoint. One of the things that you can get, which is kind of nice for the Nano VNA, is they sell these little RF demo kits, and so it's a little surface mount board, but it has some interesting things that you can measure with the Nano VNA. It has various filters. It has various components, capacitors, inductors, combination of capacitor inductors. It has attenuators. It has a built-in calibration kit. It uses these really small, I think they're called 2.4 millimeter connectors, which are a little bit of a pain. I wish they made the board bigger and put SMA connectors on here, but they decided to use these smaller 2.4 millimeter, but they provide cables for the 2.4 millimeter to SMA so that you can connect these to the Nano VNA. These are just some of the various things that you can get on those boards. You see a low pass filter, high pass filter, band pass filter, a band stop filter, or notch filter, some known SWRs, capacitors, inductors, and then of course the open short load through. There's a 5 dB attenuator and a 10 dB attenuator, so you can measure a bunch of stuff with the Nano VNA, and you can learn a lot about how to use the Nano VNA with some of these various devices. So I hope this presentation provided some insight on what the Nano VNA is and how it works, and kind of a bootstrap to help you figure out how to use it. You can, I would, like I said, highly recommend that you join the Nano VNA user group on Groups.io. And after this session, if you have questions and you're stuck or whatever, please feel free to send me an email. I'll be glad to help you out. My email is my call sign, WA1JXR at Comcast.net, or WA1JXR at ARRL.net will work also. Thank you so much for your attention. And now we're going to go over to the question and answer period. No audio, Paul.
There we go. How's that? A little better? Thank you.
A little better.
All right. Thanks, everybody, for joining us today. Your moderator, Paul, W1SCX, and I'd like to introduce Greg Algieri. He's the technical coordinator and my boss for the Western Mass section. So we can get started on some of the questions. And the first one is from our section manager, Ray, and he's just saying hi and
hey, Ray.
glad to have you on board, Ray. So there we go. All right, next up, remove the standby. Yeah, we got that out of there. Somebody, that's okay. Graphics too low. Okay, let's get to some real questions. There we go. We can get the connector savers, Greg.
I ordered mine on online. I think you can get them on eBay, even on Amazon, actually. So just look for SMA male to female adapters.
There you go. All right. If you have access, you can get them there. All right. Looks like some of these questions are already being answered. Yeah, and that's something they put in new, so everybody can see the questions. That was a big improvement in the platform. All right, let's see here, and also another supply is American Radio Supply. What we got here? All right. Latest has a lot more options in the menus.
Yeah, there's some newer versions and some newer firmware that have a bit more options. Very similar in nature, but they've, as with everything else over time, they add more stuff.
Okay. All right. And do we need to recalibrate it every time?
If you change the start and stop frequency range, then you should recalibrate. But if you're measuring over the same range and you calibrated recently, then you shouldn't have to recalibrate. Like I said, when you do the calibration, you can save that calibration in one of the memories, and then you can recall it as part of the setup. But like all RF instruments, they do drift over time. So, if you calibrated a week ago, the calibration, it doesn't take that long to do. I would recommend doing it again.
Yeah, not to mention the fact if you change anything like your frequency or any of the adapters, you should redo that calibration.
Yeah, if you change anything in the cabling or the adapters or anything, then you have to do a recal.
All right. And where can we get the test demo board?
I got it on Amazon, I believe. I just did a search for Nano VNA test demo board. They actually might have a link to it on the Nano VNA groups IO. There's a lot of links in there. I don't remember. It was a while ago when I bought mine.
Yeah, I bought mine with at the same time as well, and they had a package deal with the VNA and the board.
Right.
All right. Is this segment feature only available when using a PC?
Yes. And in fact, I just realized when on the video, I actually made an error. I said that the native firmware on the Nano VNA had each trace has 1,000 points. It's only 100. It's 101. And so that's why having the segment feature where you can, multiply that by, 10 or 100 or whatever, it takes a little more time, but it stitches all those segments together with 101 points in each segment. So you get better resolution. But yeah, that's the only way you can do that is when you're using the PC software. The native firmware in the Nano VNA itself is only 101 points per trace.
Okay, very good. And measure the effectiveness of a common mode choke at a specific frequency.
Yeah, there was actually in the QSO Today Expo, there was either the last session or the previous one, which all of the sessions are available, I believe. There was a ham who gave an excellent presentation on measuring the effectiveness of common mode chokes using the Nano VNA. So you might look that up. Essentially, what you do is you measure the insertion loss going through the common mode choke, and obviously, if the insertion loss is high, then the common mode choke is working well at choking off those frequencies that you don't want to get back down the coax.
All right. How do you connect the Saver software?
So you just load it onto your PC. The Nano VNA comes with a USB cable. You just plug it into the Nano VNA and plug it into the USB port on your PC. Bring up the Saver software. There's a button that allows you to connect the USB port, and it will go out and find the Nano VNA and connect it to the software.
All right. Okay, different version of the Nano VNA. Any recommendation to size version?
I don't have any particular recommendations. There are a lot of junk out there, so you have to be a little bit careful. There's a lot of clones, and a lot of the clones have hardware that doesn't work very well or has errors in it and doesn't work over the whole frequency ranges. Like I say, there's a lot of junk out there. I believe on the Groups IO Nano VNA site, they have a list of, I guess, what they consider reputable dealers. In the United States, I bought my Nano VNA from a ham radio store here in the U.S. It's very good. RNL Electronics. They're out in Ohio, and they carry reputable hardware and excellent prices. And I've had very good luck with them.
And that's where I got mine as well. All right. Black Widow, I'm not quite sure what that's about. See, best place to get the latest firmware. That's a good question.
I believe there's links to that on the Groups IO site.
Okay. And having VNA F, any difference in them or other than the size?
I think the firmware may be a little bit different. I think that may have some newer firmware, but I don't have an F myself, so I don't know. But it's very similar.
Okay, and used as part of a power meter with appropriate attenuation. What's the max power we can input?
Very low. I mean, these are, as you saw in the specs, the thing puts out 1/10 of a milliwatt, so it doesn't want to see much power. It's really not intended to be to measure absolute power. It's really set up to measure networks. So it's putting out a signal, and then it's looking at the reflected signal. So you really can't use it as a power meter. If you want to do something like that, then what I would recommend you get is a device very similar to the Nano VNA. It's called a Tiny SA, a Tiny Spectrum Analyzer. With that, you can measure, absolute power coming in dBm or milliwatts. But that also is a very low power device, so you don't want to put more than 0 dBm or 1 milliwatt into the thing. So you would need appropriate attenuators and so forth if you're trying to measure anything above that.
All right, and go back to this question. You got a number of them out there. Be careful where you buy them, right?
Yep. Like I say, I believe the Nano VNA Group's IO site has a list of what they consider reputable, and then R&L here in the States is a good place.
Yeah. Any books out there that you'd recommend?
There's a bunch of text books listed on the group's IO site. Some of them you can download; they're just PDF files. And so there's a plethora of information. There's also a bunch of good videos on YouTube as well. Just search Nano VNA, and you'll see a bunch of stuff come up.
Yeah, about the best videos that I've seen out there are from Al and W2AEW. Go to YouTube.
I was trying to remember his call, but he has some excellent ones.
Yeah, go look. Whiskey 2 Alpha Echo Whiskey. He's the technical coordinator in New Jersey. So look him up, and if you want to know anything about scopes and spectrum analyzers and VNAs, he's a great source. Great guy too.
Excellent. Yep.
All right. Anything to be avoided? Like I said before, probably just go to a reputable dealer like R&L or others.
Yep.
All right. Firmware upgradable. Yes, it is.
Yep.
All right. And let's see. The marker, sometimes it's hard to get it on the curve off scale. How to bring it onto the curve? I'm not quite sure what that question.
Well, with the if you're using the Nano VNA itself, once you turn the marker on, you use that multifunction switch, and as you rotate it left or right, it moves the cursor on the trace. If you're using the Nano VNA Saver software, then you can just take your cursor and your mouse and just click on the trace, and it'll move the cursor to that point on the trace.
Yeah, I can do a quick share on that, and we'll come on. Maybe I can. There we go. Yeah, I've got that up, and you can see I'm on the marker here and moving up, and you're watching all the parameters change. If you look in the marker 1, sort of center left, you can see all the different parameters changing, and you can select it for a specific frequency. Let's get back to here. All right. Right. Nano Saver file has a file ext or what will open. Okay. I'm not sure about that question.
Yeah, no, me neither. I haven't used that.
Okay. Got to experiment or get Windows to go look for it. what the letters, the downside and the screen indicate. Sometimes they're capital letters, sometimes small. I'm not sure what that.
No, I'm not either.
Okay. Um, uh, if you want, go ahead and get that question over to Greg directly on his email, WA1JXR at ARRL.net.
Yeah, send me an email. I can look at my Nano VNA screen and see if I can figure out what that is for you.
Oh, okay. Here we go on the F version, looking May 2020 QST. There you go. Connectors, do you recommend?
I don't have any. I mean, of course, reputable connector manufacturers like Amphenol and Microcoax and different places like that. But for most cases, what we're doing as hams with the Nano VNA precision, connectors aren't really necessary. When I was working in industry and we were doing stuff all the time up in the microwave range, then it was really more important to have precision connectors. But especially if you're measuring an HF, it's not all that critical. But you shouldn't have a problem. I think the ones that you can find on Amazon and or eBay should be fine.
Even the connector guys that always seem to show up at the local ham fest.
Right. Yeah. Ham fest is another good place to find them.
All right. That 7-zip can usually open those compressed files. So I hope that answers the question. Let's see. That came up before. So there you go. And that seems to be the last question. And anybody else want to get something in, go ahead and type and press enter now, and we'll get those questions answered. Otherwise, if you just want to go to Greg, WA1JXR at ARRL.net. Greg, anything else?
No, I want to thank everybody for. We'll wait another couple minutes here, see if we get any more questions in. But I want to thank everybody for attending the seminar today. Hopefully, I know it was brief, but hopefully, if you've never used a network analyzer before, then this gives you a little bit of insight. The network analyzer is a great tool. I mean, for $50-$70, what that instrument does from a measurement point of view is just a real bang for the buck, certainly. And and because it's a vector measurement device, what that means is it's not only measuring the amplitude of the signal, either reflected or through, but it's also measuring the phase of the signal. And once you can measure the phase of the signal, you gain a lot more information in that you're able to determine the real and imaginary parts of the impedance, i.e. the resistance and the reactance, and really be able to measure things very accurately. And the fact that you calibrate the device with a known standard short open load and through, you really get very accurate measurements, more accurate than some of the other antenna analyzers like the MFJs and so forth. So it's really a great device. I highly recommend that you pick one up, and hopefully this video help you with figuring out how to use it. Like I say, there's like zero documentation that comes with it. So if you've never used a network analyzer before, I can see where for the average ham it would be very daunting to use. But with a little bit of help, you can set the thing up and do some really good measurements, both in 1-port and 2-port devices. So
yeah, if it wasn't for the steeper learning curve with these devices, I'm afraid you'd be putting MFJ and Rig Expert and all the rest of the of these expensive analyzers out of business. I mean, for a $50-$60 investment, it's the best thing going. But again, the learning curve, and There's also a version I've seen out there that has N connectors on it, so they're a little more sturdy and a little bit easier to
use. Yeah.
to mate up. Yeah, so
Yep.
keep that in mind too. Search for the ones with the N connectors if you're doing a lot of that kind of stuff. So different connectors on the VNA. Okay, so if you have different connectors in the VNA or standards, Cal standards, you need specific. Well, Greg wasn't too thrilled with this, but let me go to my document.
No, you were fine.
Okay, we'll go
I'm
to
just saying, yeah.
we'll go to the document cam, and what I ended up doing was ordering some of these guys here. They're the SMA to SO239.
Yeah, SO239s. Yeah.
And then made my own standards out of some resistors and just a short circuit and an open circuit PL259 connector, and that seemed to work out just fine. So if you're doing in the PLs, and of course you got to calibrate with those on, and of course you have the fact that these things start to become serious impediments once you get into VHF and UHF. So just keep that in mind. But I thought that was another way to make things a little bit easier when handling the VNA.
Yeah. So wherever you do the calibration, if you do it right on the analyzer itself with the SMA cal kit that comes with the analyzer, that becomes the reference plane for the calibration. If you then add a adapter or a cable onto that to hook up to your device under test, then that cable becomes part of the measurement. And so that's going to add some inaccuracy, probably very small, especially at HF frequencies. It's not going to matter because the wavelengths at HF are so long. But if you were measuring up at 500 megahertz or 900 megahertz up in the higher ranges, it might matter more. But wherever you do the calibration with the short open load, that becomes the reference plane for the measurement that you're going to do.
Yeah, and those cables that come with it, you want to do a calibration when you're using those cables. As with my SO239 type, you do the calibration with that, and when you do the through, I just put in a PL to PL male adapter, and that way I can do my my through, and I'm relatively good. One other thing to keep in mind is that the VNA does have a compensation for an extended cable. So you can compensate for extended cables in there, and it takes the propagation delay out of the picture for those higher frequencies and those shorter cables that you're going to be using.
Right. Yeah. No, there's nothing special about the cables that come with the Nano VNA. You could use. I mean, you want to keep it short. I mean, ideally, what you should do, if you really wanted to do a very precise measurement, is when you take the Nano VNA, you notice it comes with 2 SMA male-to-male cables. You should put those cables on the Nano VNA, and then you notice also that the Nano VNA comes with a SMA to SMA bullet, and so you should put that bullet on the SMA male connector at the end of the cable that you're doing the calibration on, and you put the short open load through then on the end of that bullet. You do the calibration there, and then when you do the through connection, you just use that bullet to hook up the other SMA male cable in order to do the through, and then that gives you the shortest through connection and Now the reference plane is at the end of the two SMA male-to-male cables, which you can then put a small adapter on, like an SMA female to SO239 or whatever, to hook up to your antenna or your 1-port or 2-port device. So that'd be the ideal way to do a CAL.
Yeah, and thanks, Greg. And the man cave. Let's see, a place where you keep all your favorite stuff and do what you want. It used to be called your life, but now you got married, and now it's just a room. Hope that answered the question. All right. Let's see here. We got a couple of more minutes. Any other questions that come in before we knock off? Yeah. I guess we'll clear out. Greg,
okay.
Any final comments?
Yeah. Once again, thank you everybody for coming. I hope you found the presentation informative. And once again, if any questions or thoughts come up further down the line as you're using your Nano VNA, you get stuck or whatever, don't hesitate to send me an email, WA1JXR at Comcast.net or ARRL.net. We'll get the email to me. Thank you all.
All right. 73, everybody. We'll see you soon. Thanks for joining us, and enjoy the rest of the program.